let's multiply and divide some rational expressions. And we've already done this in a sense with rational expressions that were just one fraction where we would reduce it. Well, now we're just going to multiply or divide them. So with an example like this, your first thought might be, oh, I need a common denominator. Now wait a minute, I don't need a common denominator if I'm multiplying or dividing. If I'm adding or subtracting, I do. So in this case, what I could do, and I'm not, but what I could do is multiply straight across the top. Don't write this. You could multiply straight across the top and you get 42. And you do 8 times 35 and you get 280. And then when you do that, you would reduce it. So what goes into 42, that also goes into 280, and you would reduce that whole thing. And yeah, it would be great. I'm not. And the reason I'm not is because sometimes these numbers get really big. So let me go back to where this whole thing really was getting started. Let's just look at these and factor them. And I'm starting with a very basic, almost elementary school example, just so when we get to the variables, we'll understand what's going on. So let's see, 7 divided by 8. Well, 8 is 2 times 2 times 2. And I'm going to multiply that by 6, which is 2 times 3. And then 35, which is 5 times 7. And I hope you notice what's going on here. We have just factored this into its prime factors, which seems very basic and seems very elementary, but again, when we get variables involved, things change a little bit. So as I look at that, I think, well, what can I do? Well, let's cross things out that are in the top and the bottom. Well, in this case, the top is all of this and the bottom is all of that. Because if I was to multiply this, I'd have 7 times 2 times 3 over here. And I'd have 2 times 2 times 2 times 5 times 7 over here. And I'm not going to do that step because it would be a pointless step. But basically, anything on the top can get marked out with anything on the bottom if you're multiplying. So let's do it. I'm going to switch colors here. We'll switch to orange. And I'm going to cancel out any factor I see on the top and the bottom. I see a 7 here and a 7 here. And the way I was taught this was to look at it as like this. So 7 goes into itself one time, 7 goes into itself one time. That comes in handy in case you need to remember that there's an understood 1 there for some reason. 2 goes into itself one time, 2 goes into itself one time. And so I don't need to deal with these because I don't have anything up here or here that will cancel with them. So my final answer is not quite yet, but my final answer would be 1 times 1 times 3. And the denominator would be 2 times 2 times 5, so 4 times 5, so 20. And that does not reduce. It doesn't reduce because we did all the reducing we could do here. Okay? So we know how to do this. We've seen it before. We're multiplying across the top, multiplying across the bottom, but it's best, personal opinion, if you go ahead and factor and then cancel out your factors that you have in the denominator and the numerator. So let's do another one. And this one is going to be, let's use a red marker. This one's going to be division, and you've seen this before. So 1/2 divided by 7 over 10. You've seen situations like this before. First time you saw this in elementary school, you thought, whoa, way too much going on here. And it's super easy, and you might have heard it this way. Keep it, change it, flip it, and it works. So we're going to turn this into this. And again, I'm starting with a basic problem, so when we get variables, you'll know what to do. So 1/2 times, and then flip that over. So a lot of people get mixed up and they're like, well, what do I flip and what do I not flip? And if you have division, then you keep this one and then you change this one. It's going to change to a multiply. So we're going to change it to multiplication. And then you flip this one. And I say flip, the mathematical word is reciprocate. Let's reciprocate it. But we're flipping it over. Okay, so at this point, I'm going to factor, and this might look like pointless work, and you might say, oh, that's just 10 over 14. I hear you, you're right. I'm going to actually do it this way. This is 1 over 2 times, and then this is 2 times 5, and there's a 7 here. And then I look at this, and I grab my orange marker that you can barely see, and you can see the marker, you can barely see the ink. I'll cancel that out. It's not an invisible marker. It's just invisible ink. 1 times 1 times 5, that would be 5, and then 1 times 7, which would be 7. So we've done 2 very basic examples. Now let's do some that have variables in them and things start getting a little bit trickier. So let me erase that one and this one. Red doesn't erase nearly as well. The next example is going to be multiplication, and I'm going to have 9h plus 9. I've got my notes right here. I'm looking at them. It's not written on the floor, I promise. H squared plus 12h. I don't write math problems on the floor of my house. That would just be awkward. Walls maybe, but not the floor. Because I guess technically I am writing a math problem on the wall right now. h plus 2 is over here, and then 3h plus 3 is right here. Whoa, there's a lot going on all of a sudden. The last problems were super easy, and these are not. But you know how to do this, right? Remember just a few minutes ago when I said, oh, if you're multiplying, multiply across the top and multiply across the bottom. Now, things would get tricky if we were like, hey, let's FOIL this. Don't. Let's factor, and then we'll cancel things out. So I'm going to look at every individual piece. Top left, bottom left. Top right, bottom right. And I'm going to factor, and then I'll cancel out whatever I can, and then it gets really easy really fast. So I'm going to bring it down. So this is going to come down here. So in a minute, I'm going to have fraction times a fraction, okay? And we'll just talk about one thing at a time, and this is so super important. I'm going to take this marker, and I'm going to write over here, look for a GCF. That's almost always what I look for first. So I'm going to look for a greatest common factor first every time. Do you see a greatest common factor here? And the answer is hopefully an obvious yes. 9 is my greatest common factor. 9 factors out of both of those, and that leaves me with h plus 1. Okay, can this factor any more? And the answer is no. So this piece is completely factored. Let's move down. Is there a greatest common factor here? No, other than 1. Well, that doesn't help. So now let's just go for regular factoring, the way we're traditionally used to it with this. So h squared becomes h times h. Two numbers multiply to give me 20. Your first thought might be 4 times 5. That's great, but 4 plus 5 doesn't give me 12. Two numbers multiply to give me 2 and 10. 2 plus 10 is 12. Yes, so 2, 10. Immediately, here's where my mind goes. Maybe I can cancel. No, I can't. Nothing yet. We'll cancel later. Up here, is there a greatest common factor? No. Is there anything I can do to factor that any further? Because this is not squared, I'm kind of out of options right now. So, because it's linear, it's h to the first. Is there a GCF here? Yeah, it's 3, and that gives me h plus 1 here. Okay, time to grab the orange marker, move this eraser out of the way, and let's start canceling some things that cancel. So any factor you have in the numerator and denominator cancels as long as you have multiplication here, and everything is multiplied. This is like 9 times h plus 1 times h plus 2. Some teachers put parentheses around that just to kind of show you that everything is multiplied, and it works. Okay, let's start canceling. There's some obvious things here. Let's see, there's h plus 1. That goes into itself one time. I'm not going to put the ones here. There's an h plus 2. And you might say, oh, yay, we're done. And sure, fine, whatever. You could be done, but you'll still have work to do when you think you're done. So I'm actually going to move ahead and pretend like I don't notice this. And so on the top, we're going to have 9 times 1 times 1, so 9. And in the bottom, we're going to have h plus 10 times 3. Let's put the 3 in the front because that just looks nicer. And I could have simplified this already, but I didn't. We think we're done, but we're not. And here's why. These are subtle. 3 goes into 3. 3 goes into 9. So what I could do is, instead of saying this is 9, I could have erased it and put 3 times 3 and canceled one of those 3's. So like if you want to, and you don't have to write what I'm writing here, but this is not the final answer, I'm going to put 3 times 3 just in case you need to see what's really about to happen here. And then I cancel this 3 with this 3. So you can cancel out numbers that are factors, and that's a tricky thing to understand, but let me tell you what you can cancel out and factor. If you had, like I just did, then I put an X, but that's okay. I can cancel this 3 with that and put that, but what I can't do, and this would be wrong, I can't do this. I can't say, oh, let's cancel that 10 with that 10. No, you can't cancel with that 10. And here's the reason why. This 10 is part of another quantity. It's part of this factor of x plus 10. And so I can't just reach in here and take away this because of that addition right there. All right, let me erase that. Now we have the final answer. There it is right there. That's it. All right, I'm going to make a separate part for this lesson. I'm going to do the next 3 problems on a second video.